So here we want to find the area of the sector, and this is similar to finding the arc length. If we look at how the formula is made up here, it's saying the area of the sector is equal to the area of the entire circle, which is pi r squared, times the portion of that circle, which is just theta, or the angle, that reference angle, divided by 360. So this is the formula we're going to use when they give us theta in degrees, which they do. 60 degrees is going to be theta. So theta is equal to 60 degrees. And then they give us our radius of 10 inches. We'll put our units in there. So area of the sector is equal to pi times our radius squared. Our radius is 10 inches. I'm going to keep the units in there now so that you can see what happens to the units as we go throughout the formula. And then 60 is theta. 60 degrees is theta divided by 360 degrees. This is a parentheses, not a 1. Okay, so then it's just simplification from here. 10 inches squared becomes 100 inches squared, or 100 pi inches squared, times 60 divided by 360. Degrees divided by degrees cancels, and 60 divided by, so we would cancel out the units here of the degrees, and then 60 divided by 360 is equal to 1/6. So now we're just dealing with inches squared, and we'll simplify from there. That becomes 100 pi over 6 inches squared, and then that reduces to 50 pi thirds inches squared for our final answer. And then, of course, if we're talking about area, our units are going to be squared, right? Pi r squared, we're talking two dimensions here, both a horizontal and a vertical dimension, so we're going to be units squared. If we're talking sector, if we're talking arc length, which is S is equal to R times theta, if we're given in radians, or S is equal to the circumference times the portion of the circle, theta divided by 360, then we're just talking a one-dimensional length, so our unit is going to just be to the power of 1.